Audio Jungle. Audio Jungle.
Now let me see some of the problems on power semiconductor devices concept, that is switching concept. So we know devices acts as switches in two states, on state and off state, and we have seen already characteristics, right? So that is switching characteristics and static AV characteristics of the switch. Let me talk about, or let me discuss one of the problem on this switching transients. This is the waveform given. The question is, the figure shows voltage and current variations of the device during a switching transitions. Then the transition of the device and energy lost during the transition of dash. The options are given, these are the options. So the given waveform is the variation of voltage and current of the given device. Let me see what type of transition it is, then what is the energy lost during that switching transition. When you come to this waveform, observe this, the voltage is decaying, that is decreasing, current is increasing, right? The voltage is decreasing, current is increasing. We know in which switching transient voltage decreasing, current increasing. Definitely that is turn on transition. When switching goes to on state, the voltage gradually decreases, current gradually increases, right? Then it goes to on state completely when voltage reaches to on state drop, current reaches to final steady state or rated current through the device. So definitely the transition of the switch is turn on transition, right? The next is, what is the energy lost during this transition? So we know the formula, energy lost is, so energy lost is equals to 0 to T on V into I into dt. This is the standard formula we have to calculate energy lost during the switching on state, switching turn on transition. So here this is the total time period during this voltage decreasing and current increasing, that is on. So instead of using this is nothing but what does it give? Integration is the area of this curve, right? So now here when you come to this variation, this is the current variation, this is the voltage variation. So 0, this is the T1P, time period is the T1 to change the current from 0 to Is, time period is the T2 to change the voltage from Vs to 0. So if you find the area of this complete curve, that gives the energy lost during the turn on transition of the switch. So this a curve has two triangles. When you observe clearly, this is one triangle, let us take small triangle, and this is a bigger triangle. Let us say O, A, B and B, C, D. There are two triangles in this waveform. So energy lost, total energy lost is equals to area of triangle OAB plus area of triangle BCT, that is area of triangle OAB plus area of triangle BCD. What is the area of triangle OAB here? Of into T1 base into height is the IS. What the area of OAB gives, triangle OAB? Ampere second area it gives, right? And basically what is the energy? V into I into T. Okay, so now this is the ampere second area into what is the voltage during this period, T1 period? Voltage is the Vs steady value. So I am taking Vs plus What about the BCD triangle area? That is half into T2 into Vs. From here to here, this is the height of this triangle. So this triangle area gives voltage second area. So then we know energy is V into I into T. So this is area voltage second multiplied with current. What is the current during this period? Is a constant steady current Is. So by solving this we get E lost is equals to Vs Is by 2 T1 plus T2. Vs Is by 2 into T1 plus T2. So when you come to the options, see what is the right of this, what is the answer of this question? The switching transient is turn on transient, and what is the energy lost during the transient switching turn on transient is Vs Is by 2 into T1 plus T2. So the option is A, right. So this is another problem based on the switching transients. The variations of voltage and current of a given device are given. This is a figure shows voltage and current variations of the given device during the turn on transition. Then find average power loss during turn on transition if switching frequency is 100 Hz. So when you observe switching characteristics of the given device, the voltage is decreasing, current is increasing. Definitely this is a switching turn on transition. So what is the average power loss during this switching transition? We know how do we calculate power loss of switch during switching transitions. Average power loss is equals to 1 by T total time period 0 to T on V of T I of T dt. This is a general way. According to circuit theory, we know how to calculate average value of any periodic signal. So this is a during turn on transition average power loss. What is the V of T from this variation? What is I of T from this variation? V of T is equals to, this is a line which is not passing through the origin. Then what is the straight line equation? In general, that is use y is equals to mx plus c, straight line equation. So from this we get V of T is y of x is y is the V of T, x is the t. What is the slope of the line? Slope is, here it is 0 comma 600, and it is, let us take this is the t on, right? T on comma 0. So with this we get minus 600. So let we take first in terms of V and I. It is a V by T on into T plus C. Substitute any value on this straight line equation to get the constant C. So therefore we get V of T is equals to V minus V into T by T on. This is equation number 1. Then what is the I of T expression from the given variation? I of T, this is the line passing through the origin. The straight line is y is equals to mx. So we get directly I by T on into T. This is equation number 2. So how we are getting these two straight line equations? By using these two. Y is equals to mx plus c for the voltage variation. Y is equals to mx for the current variation. Now if you know these two expressions, substitute in the average power formula. P average is equals to 1 by T 0 to T on V minus V by T on into T, I by T on into T into dt. So by simplifying this we get, multiply these two, 0 to T on, Vi by T on into T minus Vi by T on square into T square dt. 1 by T T on, Vi by T on into T into dt minus 0 to T on, V by T on square into T square into dt. Now integrate separately and substitute the limits. We get one by T. Vi by T on is the constant. T integration T into dt, T square by 2, limits are 0 to T on minus Vi by T on square into 0 to T on. So by substituting this limits in this equation, we get finally T Vi by 6 into T on, final expression, right? Therefore we can write as P average during turn on is equals to Vi by 6 into, can I write it as 1 by T is equals to Fs, that is the switching frequency. What is the T here? Switching time of the switch. So F into T on. This is the expression you have to remember the examination point of view, right? So that is a formula we are deriving from the data. Now substitute. The question is what? The variations are given with the values, right? Voltage value given, current value given, and T on also given. Switching frequency also given in the data. Substitute all these values. So therefore P average is equals to V is how much? 600, I is 100, frequency is 100, T on is 5 into 10 to the power of minus 6 divided by 6. So by solving this, we get finally average power loss during the switching turn on switching transition of the given device or switch is 5 watts. So the answer of this is 5 watts. So this is the problem based on conduction loss during on state. The question is a power electronic switch which has an on state resistance of 0.12 ohms and carries the current shown in figure. Then what is the conduction loss of the switch? As we know that according to the data, the switch is given with the on state resistance. So this is the switch, let us take a power electronic switch which carries the current I of t shown in figure, which has a resistance R on is what? 0.12 ohms. So this can be represented now with given circuit, one of the given circuit models, right? So that is, it has only the on state resistance R on equals to 0.12 ohms, then I of t. So how do we calculate power loss of the switch with this circuit model? P conduction state or on state is equals to I RMS square into R on. So how do we calculate RMS current of this periodic current. We know according to circuit theory, if have any periodic signal, we can calculate IRMS, that is 1 by t integral 0 to t I square of t into dt under square root. So now here we get directly from this is a sawtooth waveform, right? So we know if the waveform is a sawtooth, then its RMS current is definitely peak value divided by root 3. We know that. That is not empirical, it is a derived based on the formula. So you have to remember when the waveform will be like this. This is a method. So IRMS is what? 5 square by 3 into t by 2 plus divided by total time period t square root. This is the IRMS. So how much you get here? T will be cancelled, 25 by 6. So then what is the on state power loss? On state power loss is equals to 25 by 6 whole square into 0.12. That is 25 by 6 into 0.12. Therefore, P conduction loss or on state loss is equals to 5 watts. This is the answer. But you have to remember, I have written this is a direct. You can do with equation mode. Just write it down the equation, that is y is equals to mx. Then I of t is equals to, what is that? 5 by t by 2 into t during the period 0 to t by 2. T by 2 to t period, there is no current in the switch. The only during on state, the current is carried by this amount of current during the switching on state. This is off time, right? So what is the total time period is t. After this t period, the cycle will be repeated. So I have taken directly here. If you use this formula and use the standard formula, that is 1 by t integral 0 to t I square of t dt square root, then again you get square root of 25 by 6 amperes. So finally, what is the answer of this question? On state or conduction state power loss is equals to 5 watts. So this is another question based on the conduction loss of the switch. The question: a power electronic switch has on state voltage drop of 2 volts and the current carries shown in figure. This is the current variation through the power electronic switch. Then what is the average on state power loss of the switch? So from the given data, the data is given with power electronic switch has on state voltage drop of 2 volts. That is, the switch is now represented with on state voltage drop, that is equals to 2 volts. The current carried by the switch is I of t shown in figure. So this is the model of the equivalent model of the given switch. Then what is the power loss of the switch? How do we calculate power loss of the switch when this is represented by this model? That is P on state, average on state loss is equals to Vt into I average. This is the formula. So Vt value is given with the 2 volts. Then what is the average current of this current signal which is flowing through the switch? So average current is equals to, basically what is the average value of any periodic signal? The total area divided by the total time period. So what is the time period of this current variation? The time period is t. Because after t, the waveform will be repeated. So this is the time, one cyclic period of the given signal. So total time period is t. What is the area of this curve? 0 to t by 2 only the current variation, t by 2 t period the current through the switch is 0. So now calculate what is the area of this curve during the period 0 to t by 2. So when you come to this curve, it has two variations. This is one triangular and second one is the rectangle. Find the area of triangle as well and rectangle, and sum of these two areas divided by the t gives the average value of the current signal. So what is the area of the triangle? Half into base is what? T by 2. The height is what? This is the height. So 10 minus 2, 8 amperes. 8 plus the area of this rectangle, 2 into t by 2. So what we get? If we take the t common, t will be cancelled, is a 2. So answer is 3 amperes. So I average of the current signal is 3 amperes. Then what is the on state power loss? P on state average power loss is equals to Vt value is given with 2 and I average is 3, then answer is 6 watts. So this is the answer of the question. So this is another question on the third model. So a composite power electronic switch carries current as shown in figure. This is the current variation. Then what is the conduction loss of the composite switch? So what is the composite switch? This is combinedly we can call it as a switch. This is one switch. The switch has two different characteristics of the switches. One is the MOSFET, second one is the diode. The combination of MOSFET and diode is the one composite switch. So the switch is the MOSFET and diode combination has on-state resistance of the MOSFET given with the 0.15 ohms. On-state drop of the diode is given with 0.6 volts. So this is the current variation of the switch. The current flowing through the switch is I of t. How do we calculate conduction loss of this switch? This is the model 3 in which can be represented with on-state. Switch can be MOSFET with the on-state resistance. This is the RDS. And the diode with the on-state drop. The current carried by the switch is I of t. The values are also given. Now what is the power loss of this composite switch? Coming to this on-state or conduction loss, I RMS square into R on plus VD into I average. So general, why do we take RMS quantity in case of resistance? We know that from the circuit theory. When heat comes into the picture, you must calculate RMS quantity of the signal. So this is the resistive part. When you supply energy to the resistive part, resistor can be dissipated the electrical power in the form of heat. So now you have to calculate RMS quantity when subjected to the resistive element. So now calculate RMS current of the given current signal. This is the current variation given. What is the total cyclic period of this? T is equals to 20 seconds. T in terms of seconds. After 20 seconds, the waveform will be, same waveform will be repeated. So in this variation, 0 to 10 period current carried by the switch, 10 to 20 there is no current in the switch. Now find out what is the average value and RMS value of this given current signal. So I am calculating directly. This is total time period 20. This is again ramp variation, that is 12 square by 3 into 5 plus 12 square into the time period is what? 10 minus 5 is the 5 whole square root. That is, if you take 12 square is the common, that is 12 into square root of 5 by 3 plus 5 divided by 20. Therefore, IRMS is equals to 12 by root 3 amperes. Then what is I average? I average is, as usual, total area divided by total time period. What is the total area of this curve? You are getting the variation of I of t between 0 and 10 only. So in this time period, the curve has two parts. One is triangle, other one is rectangle. So what is the area of the triangle? Half into 5 is the base into what is the height of this? 12 triangle plus area of this rectangle is 12 into 5. 2 into 6 are 6 5 are 30 plus 12 5 are 60. That is 90 divided by 20. The answer is 4.5 amperes. So average current is the 4.5 amperes. RMS current is the 12 by root 3 amperes. Now substitute these two values in this expression. What average, therefore, on state or conduction loss of this composite power electronic switch is 12 square by 3 into 0.15 plus 4.5 into 0.6, 0.05. Now the on-state conduction loss of this composite switch is total 9.9 watts. So this is the answer of the question. On-state power loss is 9.9 watts.